Okay, guys, welcome back. This is the second part of the machine learning macro course from Kaggle. All right, so the first part, if you follow the video, I was just trying to explain about the simple model of decision tree, and we are using housing, how to price. Imagine you're in a real estate business. How do you price a proper house so you don't you want to make money, right? All right. So we are now on the second part. We are going to examine the data. Here we go. Ooh, searching for dark matter. That's it for another course. um, I'm just behind my house here, where I'm in the backyard. That's why you can see all of this green. I'm just under the tree, trying to just get off the house, cabin fever. So that's about the nice thing about working on your own. The hardest part probably sometimes I feel kind of lonely, but I'm kind of used to it right now. Not so much. I was thinking to get probably a cat or a dog. But right now it's a summer holiday, so I'm here with my kids. They are like 15, 13, and 11 years old, so I'm fine. And my mom is just visiting me from Indonesia, so that's good. But otherwise, when the school is over, I kind of feel, yeah, a little bit, but I'm kind of adjusting to this kind of a way of like living. This is going to be the future, remote working. I think so, but I believe that the working in the office is not gonna go away soon. It's just another way of working. I think there are, I think, use cases where you still work in the office. Especially if you are like in the same geographical area that you can get all the talents there. The hardest part would be probably if you cannot get the talent. But I think in the future, I think it's gonna get. I don't know. I felt that. Yeah, yeah. I just feel that this is gonna be a good trend in the future. The remote is gonna be bigger and bigger. Yeah, and you can like set up your own schedule. The thing is, you have to be like really disciplined on the yourself. You have to take away your smartphone. No distraction and all that stuff. Okay. So anyway, that's just a side talk. Sorry about that. We are back on the machine learning microcourse from Kaggle. Um, just to let you know, I'm not get paid. I didn't get paid to do this. I just love exploring things on my own. For the time being, I love. My background is in electrical engineering. I have also a master's in business, but that doesn't really count. Um, so yeah, I'm just trying to learn new things here right now, and I think I kind of like this combination between of data and computer science. Not so much just like writing software, but more about there's a mathematics to it because I was exposed to a lot of mathematics when I was studying engineering. Um, although I'm not a really like genius in mathematics. My math is just like sometimes I even got C or even. I remember when I was in a again side talk. I was engineer trying to graduate. I got, I think, math four is talking about like calculus or like like just like advanced mathematics, and I couldn't get past a B. I only get C, and I was like so determined I want to get at least a B. So I think I kind of retake it like until two times or even three times, and then I get B. Okay, I'm good. I don't have to get A. So anyway, so don't let the mathematical equation like scares you. This is what I learned over the years as I grew older. If you don't understand it, if I don't understand it, it's not my fault. Um, I just have to learn a different way, getting from different input, different sources. it could be the other party fault because they couldn't explain it clearly, right? So that's the way I look at it. Um, yeah. So right now I'm just trying to concentrate on the this intersection between data and deep learning and the computer science, right? And then I'm trying to also try to gauge what area because I live right now in Indianapolis, right? And over here, healthcare is big. Elali is one of the major big companies. My wife works for there, so I'm thinking probably I should probably go towards there. You know, like deep learning and or data science for like life sciences or like for healthcare. And it's exciting. There's so many opportunities. You know what they say, right? You have to find a work, something that you love, something that you are good at. What is something that you're strong at, good at, so you can contribute to society, but you don't hate it. You like it. You love doing it, and it's valuable for the people around you, for the community or for the world. So if you can find that intersection, so I'm I'm yeah, I'm trying to get back on my feet here after being like with the kids the past, I don't know, 15 years probably. You know, staying at home with them, just raising them. Um, so anyway, that's just part of a snippet of my life. All right. So right now we're talking about pandas, right? To get familiar with your data, right? Pandas is a kind of a library that are used in data science a lot, that are being used to look at the data frame, I think. Okay. So the first step in any machine learning project is to familiar yourself with the data, right? Because it's about understanding the data. And we're using the pandas library for this. Pandas is the primary tool data scientists use for exploring and manipulating data. Okay, so we want to import. The command is like this. Hold on, hold on. Should I like okay, anyway. Okay. So you use this import pandas as PD, right? Um I'm gonna I'm just gonna get a copy and paste of this. Um ooh, I got so many things open here. I'm just gonna create another tab side by side, you know. Um, this is just gonna read through this really quickly with you, okay? So the most important part of the panel library is the data frame. It's basically like I think a Microsoft Excel spreadsheet where you got all of the columns and the header of the column and the rows, and the header of the column is sort of the header for a specific data. For example, in the real estate data, for example, the one that you want to like concentrate on determining the price of the data, for example, is the how many square feet, right? So square feet would be one of the column, and would be number of rooms in the first floor, number of room in the second floor, number of room in the basement if there's a basement. Uh, is there a swimming pool, yes or no? So those kind of things, right? So picture a data frame is like a square or rectangular with all of bunch of rows and columns, and to basically to view the data in a kind of matrix form. Oh, you can think of it as a table, right? So this is similar to a sheet. Okay, Excel and SQL. Panda has powerful methods for most things that you want to do with this type of data. For example, you look at data at home prices in Melbourne, Australia. In the hands-on exercises, you will apply the same process to a new dataset which has home prices in Iowa. Example, Melbourne data in this file path. Okay, so this is the file path in Kaggle. We load the explore data with the following comments. So basically you use this, right? You load it into the Melbourne file path, and then you read it using the PD. PD is the library from the Panda, right? So PD dot read CSV, it means just reading the CSV file because it's a CSV is a specific format of a file. You can think of, if you're familiar with Excel, is I think XLS or XLV, something like that. PowerPoint, I think is .ppt, right? What else? Um, Music for MP3 is .mp3. For movie like YouTube, you want to upload something, one of the file I think is famous is .mp4 and other format, right? So CSV is just a specific format file, right? I don't know what is it stands for. Hmm. You wanna just CSV? We can just Google it really quickly. Oh, comma separated values. That's what it stands for. It's a delimited text file that uses a comma to separate values. Oh, okay. A CSV file stores tabular data, numbers and text in plain text. Okay. Okay. Ooh, I love this. Introducing Stadia. Ooh, learn about the new gaming platform of Google. Yes. I'm excited about Stadia. If you haven't heard about Stadia, probably you want to check it out. It's like the Netflix for video gaming by Google. So the idea is you can just stream. Um, you don't need a box. You don't need a PS PlayStation 4. You don't need an Xbox. You just go online, have I think a minimum of I think like 10 megabit per second. Very low, and then you can like stream for like 720p, something like that, right? But if you have a minimum of 35 megabit per second of download speed, you can even stream for 4K with I think 60 frames per second. So that's quite exciting. Um, anyway, a little bit of tangent. I hope you don't mind. Okay, so where were we? So okay, so we just read the this Panda data frame is a comma delimited whatever CSV. Okay, it's basically a tabular data separated by comma with plain text and uh, alphanumeric. Okay, and then you want to describe. So this is what the data look like. Basically, this is what is called the data frame. This is called a data frame. So this is what it looks. That's why it looks like a Microsoft Excel spreadsheet, right? So you have all of this um, kind of rows, yeah, over here, right? And then you have all the columns, basically all of the different, the important like features that you can think of what influence an expensive like the pricing of the house, right? So there's longitude, year build, building area, land size, whether as I think I don't know, car garage probably, bedroom, right? So and then this the count, mean, standard, minimum. Okay, okay. So now interpreting data description. The results show 8 numbers for each column in your original data set. The first number, the count, shows how many rows have non-missing values. So here, the first show 8 numbers. Um, so one, wait, first show it. 1, 2, 3, 4, 5, 6, 7, 8 for each column in your. So each column there is 8 numbers, right? The first number is the count. This one, okay. It shows how many rows. Shows how many rows have non-missing values. How many rows has non-missing value? I don't understand this. Like the count is 1358. Okay. So it seems that every rows has non-missing values. Okay, they're all like has values. Missing values arise for many reasons. For example, the size of the second bedroom wouldn't be collected. So let's see, second bedroom. This one, right? There's no value here, right? If you look at okay, the second bedroom wouldn't be collected when surveying a one-bedroom house. We'll come back to the topic. I'm missing that. The second value is the mean, which is the average. Under that standard is standard deviation, which measure how numerically spread out the values are. Right. So this is like the average. So the rooms has an average of 2.9 room. The price is about 1 million, right? 1 to the power of 6. The distance is about probably like 10 miles radius. Postcode, this one doesn't make sense if you average the postcode. The bedroom is about 2.9, so it's about 3 bedroom. Bathroom is 1.5, right? Car 1.6, land size 558 square feet, and so on, right? Year built in 1964, right? And the standard deviation is the um, um, I don't know if you are into statistics, but standard deviation is the measure how numerically spread. So if you look at the bell curve, how wide is the bell curve? So probably I can just show it to you really quickly. Um, how it looks like, but it looks like a bell curve. So this one, like over here. So the higher the standard deviation is, for example, this one, right? The standard deviation. So the wider the standard deviation, so it's this bell curve is going to be wide, right? So this is going to be instead of like this, if you have a wider, so it's going to be like this. Yeah. So it's like a mountain, but it's like a instead of a high mountain, it's like a just like a low level kind of mountain, right? Which means um, the values kind of really spread out. There's nothing like really stand out. But if you have a standard deviation that it's how do you say it? Um, um, uh, Standard deviation that is like narrow, right? So the look at the mountain is like a high, really high mountain, right? Which means many of the values um, revolve on the mean, right? Because if you can imagine like the standard deviation is like this, right? Which means many of the values resolve in between 0 to 0.5, right? Probably like I don't know 50%. Over here is like only like 19 plus 19. This is like um, yeah, less than 40%, right? Yeah. So probably I can have a let's see a few more. Yeah. Yeah, so okay, so let's like this. So like this, yeah. So this is a different standard deviation, right? So the standard deviation is very small, zero point 0.5, which means the mountain is kind of high. This one is like the normal bell curve, and standard deviation two is kind of like a kind of spread out. So nobody's like really tall, or nobody's really smart, or nobody's really like kind of stupid. Let's call it. Sorry to say that word. Okay, I mean, okay. In terms of the house, nobody's. No house is really expensive. No house is really not so expensive. So probably, if you look at the minimum of the house, probably is like 100,000, right? And the maximum of the house is like a million, right? So there's a spread of like 900,000, right, between the minimum and the maximum. But the number of the house, if you look at the if over here the standard deviation is like really high, which is like which means wide, which means the difference between the maximum and the minimum it's not so much, right? So for example, if you have the houses that prices like $1 million, probably there's houses that are probably like 100 of them over there, but the houses that are value of 100,000, since the difference is not so much, probably instead of let's say 100 for the 1 million, it has like 10, so the ratio is like 1 to 10, right? But if you look at the standard deviation that's like a high mountain, or standard deviation is really low, which means there are kind of unequal kind of distribution, so to speak. So the distribution between the max and the minimum it's kind of like really big the gap. So for example, if you have the again the same minimum and the same maximum of the house, for example, if the minimum is 100,000 and the maximum is like 1 million, and you say the minimum still has the, for example, has a like a what's the example earlier I gave, like 100 of houses that are 100,000, but in the maximum houses that are 1 million, there are probably I don't know, 10,000, something like that. So it has a huge gap, right? So I think if I can give another concrete example would be what's the condition of our here in the US right now, right? So many people are like being like loud about there's a unequal uh, distribution of wealth, right? Some people are really really rich, some people are really like struggling just for daily you know just for shelter, food, and daily food and everything, right? So the one really rich probably earns like, I don't know, Jeff Bezos earn like, I don't know, like a billion for a year, something like that, right? While the one that's really struggling is like earning like, I don't know, $1,000 a year. So there's a huge gap. And then not just that, but the number of gaps, the number of people who are earning that is also a lot. So but I don't feel it's like that. I feel like the US probably is more like this, you know. Um, it's more like kind of there are probably this is I felt like uh, the one like this is more like a corrupt country. I felt. I don't know. Anyway, so but you understand the point, right? Um, let's go back to so so basically it's describe how spread out the values are. Yeah. So the more the higher the standard deviation, the more spread out the value. So for example, if you look at this, it's zero point 0.9, the room is zero point 0.9, the price 6 point. Yeah, this one is there's no point of reference. I'm not sure how to interpret this. Yeah, because I thought the standard deviation has to be like, hmm, okay. Anyway, okay. Anyway, we don't have to dwell on this. Well, we might come back to that later. Okay. So, and then there's a there's a this a minimum 25%, 50, 70, and max, right? So imagine sorting each column from lowest to highest value. The first smallest value is the minimum. So for example, if you have the minimum, again, we already talked about this 100, say the price of the house is 100,000. If you go a quarter way through the list, you'll find a number that is bigger than 25% of the values and smaller than 75% of the values. That is the 25% value. Yeah, okay. Yeah, so 25% is means like if you go, you are just like occupying that 25% all of the list. So for example, if you have a house, 1,000 houses, right? In this database, right? You have 1,000 houses, right? So 25% of that would be 1,000 is 25% is 250. So about 250 houses that have that value. This is what it means, right? So the rooms, 25% of the rooms has two rooms, right? So which means if the house is about 1,000, it has like 250, right? And so on, right? Um, okay, so now we'll go to the coding exercise. Hopefully this works because I'm like away from the house. I'm kind of like outside the house. Hopefully the oh, it still worked. Good. Hopefully the internet's still strong enough. Just gonna do this. All right. So what is this? Okay, the exercise will test your ability to read a data file and understand statistics about the data. In later exercises, you will apply techniques to filter the data, build a machine learning model, and iteratively improve your model. The course example use data from Melbourne. To ensure you can apply these techniques on your own, you will have to apply them to a new data set with house prices from Iowa. Okay. Um, so I think this course is from using Melbourne, right? This one. But now we are using Iowa. Okay. Um, we're using local from the US. Okay. So this the exercise uses a notebook coding environment. In case you are unfamiliar with notebooks, we have a 90-second. Okay. We'll skip that. Run the following cell to set up code checking, which will verify your works as you go. Okay. Okay. So we'll just run this one. In case you haven't, this is the first time you use Kaggle. When you want to run a code, for example, all you have to do is just you can click this button, or you can like click Shift written, right? So I'm doing Shift written. Setup complete. Basically, this is importing the necessary kind of library to so importing binder, importing this all of this stuff that necessary from this machine learning, right? Um, okay, so now we are reading the Iowa data. So if you haven't, if you look at this is so big. Why is it so big? I'm just gonna make it smaller. Okay, so you guys, okay, I think this is better. So here is the input, right? So you have the Melbourne housing in a CSV format, and then you have the home data for ML. So we have two basically data. We'll see what is this for, right? But this is both are CSV file, and you can actually take a look at it just by clicking it. You can see like, oh, I think I know. Uh, yeah, so this is the Melbourne, right? So it has the suburb, address, room, types, price, a method, seller, and so on, right? And then you can just go out from here, just click that. So now we are importing the pandas. Again, pandas is a library to see what the data looks like. Just imagine pandas is like a Microsoft Excel, right? So before you can use it, you have to import it first. And then you want to import also put a pointer where is the data. So this is where the data. So in Kaggle, you have to put dot dot. This one is very important. The first time I used Kaggle, I was like so confused. Like, how do I like point like my pointer to over here? Like, so I just like because there's no. I know there's a input folder here, and then there's a file here. Should I put like input and then slash Melbourne housing? Apparently it's not. You have to put like input slash directly to the um, oh actually you have to put the folder, but the one that I was confused is you have to put dot dot here, which is really important. If you don't put that, it won't work. All right, just let you know this is like small things, and it could be really frustrating. I don't know, annoying. Trust me, I've gone through that. This is part of the kind of like the frustrating thing about computer science, like the small things that like we take it for granted, like missing comma, missing dot, missing slashes. It's like can drive people crazy. Okay, so just give you a heads up. Nothing to worry about. Life is cool. Everything's still going on. Chicken is still good. Haagen-Dazs ice cream is still good, but it happens. Okay, so what we're doing right now is just set up a pointer from the training over here. We can take a look really quickly. So yes, an ID, subclass, zoning, lot frontage, lot area, street, and so on, right? Um, so this is kind of the training data that we are trying to use in this machine learning uh, session, right? And then the second one is we are going to read that pointer, that file, using the pointer that we already pointed to, and then point it, and then we're gonna put it into the home data, and then this is just to check. Okay, step one, check. So call line below with no argument to check what that you have loaded the data. Okay. Okay, so we're just gonna run this. Again, you can click this one or you can just shift enter. I love shift enter. So I'll do shift enter, right? And then you know how it's already being executed if already there's a number over here. This number two, that means it's already being executed like 2 times, right? So I think it's all good, right? And then you can see here from the console, there's an arrow over here. You can like click it and then it will go up, right? And it will, everything is like looks good here. The setup is complete. Abaton core display JavaScript are correct. You have this GPU off. You can turn it on if you want. I think it's going to run faster in this case. I forgot to turn it on. We'll see. Probably it's not a big deal because it's probably it's a small kind of data set. It's not a big one, but for the big data, you want to turn that on, right? Okay. So we are going to run the next code, which is the lines below will give you a hint or solution code, right? So the solution is, oh, home data, we did it. Iowa file path, yeah, okay. What's going on here? I don't understand. Okay, so, okay, anyway. So we are going to read the data right now, describe the data, boom, write it, okay? So we did this like from the, just like from the exercise, yeah, over here, right? With the same thing, basically dot describe, right? But this is using Iowa. That's why now the data is different, right? So here you have room, price, distance, postcode, bedroom. Over here, what do you have? I think it's kind of, oh no, it has a different heading, right? But it has the same heading for the um, the column. Sorry, my brain doesn't work. So there's a ID, there's a subclass, there's a lot frontage, lot area, overall quality, overall condition, your build, your remodel. I don't know what is this. Basement finish. I think uh, bas basement finish. I don't know SF2 basement unit. Probably in square feet. I think this is square feet. Oh, I think this is basement finish square feet one. This is square feet two. Probably there's like two areas in the basement. Okay. And then this is the basement square feet. So if you look at this 1057, yeah, so if you add this up, 567 times plus 443 plus 4 46, I think this is the total. This is the first, there's first floor square feet, second floor square feet. There's low quality. What, low quality? I don't know what is that. There's a living area, there's a basement, full bathroom, basement half bathroom, there's a full bath, half bath, bathroom, kitchen, total rooms above, great fireplace. I don't know what's the is it in terms of square feet? I don't know what's the measurement of this. And then the year build, garage cars, garage area, wood deck, open porch. Oh wow, this is a lot of variables. There's a screen porch. There's a pool area, miscellaneous, month sold, year sold, and the sale price, right? Okay, it's pretty dense, the data. Cool. Okay, so you might want to just take a look, like and get a like intuition what's the data is all about and what are those things, right? Especially if you're not familiar with the how housing is being sold, being buy and sell, what's like the more like the important uh, features that makes the house expensive or more pricey or more cheaper or not. Just want to get sense of the data. I think that's really good practice to have instead of just like going through that data really quickly and just put it inside the machine learning model and then just train it and then so it's really I think get intuition or to understand the data, right? Okay. How long have you been? um ooh, 35 minutes. Okay. Okay, I think it's almost done. Okay. So right now we are going to want to know average lot size, the newest home age, and then the average loss. We're gonna print it out. Okay. So this is like the the code for that. So home data. Why home data? Because it's remember it's already um, wait. Yeah, I think I did this. I think I did this before. That's why it has this. Anyway, yeah. Okay. So wait. Oh, sorry about that, guys. My Uber. Um, yeah, that's what I do sometimes. If I get bored, I drive Uber or Lyft. I used to use it more often before, but now I don't use it that often. I feel like um, I'm putting myself into risk unnecessarily, because it's like you're with strangers and you don't know what, I kind of trust, about the humanity that they're all doing good, but you'll never know, right? So, and my other kind of like interest is in investing in technology. Probably I'm gonna do a separate a video blog for that, investing in technology and why I think many people should do that because it's good for humanity. Yeah. The Just to put it like really simple, the main reason I do investing in technology is first to make money, and it's just not to make money, but it's to make a better world because a better world basically, because I believe in the positive roles of how technologies shape society into more progress world into a better world. So everybody can like have nice things in life, right? Um, so let me know if you're interested, but I think that's one of the interesting and important topic. After all, you get all of this money, right? You like you work like a, I don't know, engineer or as a data scientist. You got the money, and what do you do with the money, right? Right? You just kind of just put it in the bank, and you're happy with it. You earn like 2%, 3%, right? So, okay, we'll uh, I think I am gonna talk about that for like at least 30 minutes to 1 hour. Anyway, so where are we? We are here to check out the average lot size. So right, so we're using this basically um, um, a syntax called round, right? So basically, home data dot lot area dot min. Okay, this is the name of the column. Yeah, lot area. This one, right? You can see it also from here. If you open this trend CSV, there's this lot area, right? So you want to know what is the average, right? Right. Um, so you put dot min, right, on that particular from the home data, and then you want to round it because you don't want to. be bothered with the commas, right? And then the newest home age, basically you will get also the year built. Where is it? The year built, and you want the newest, so you get um, um, the maximum, right? The maximum, which is probably, I don't know, 1973 or 2000, 2010, right? Um, and then you want to subtract that to 2019 because you want to know how old are they from. So, for example, if you pick this as the newest, then this is just 9 years old, right? Okay, so we'll run this one. Okay, so it turns out that the average lot size is 10,517. It could be in square feet. I'm not sure. The newest home age is 9 years old. Could be, I think, this one, 2010. This house over here. Okay. Um, what is the average lot size rounded to nearest integer? Oh, okay. So this is basically the same thing, right? I'm just doing it over there again, right? Uh, so this is just a hint. Step two in run this. Okay, yeah, this is just a hint to for you to finish. I think I already did this like a long time ago. So this could be my second kind of video. Anyway, that's fine. I might be creating the same video 2 times already. So, okay, so it's correct, right? So 10,517, and his home age is 99, right? Um, and then what is this? You can like, you can run this one too. If you want. Let's see. Okay, so basically just running like a again like an extra spreadsheet about you want to print the build, remodel, sold, and price. So this is how you do it. So yeah, it's just a specific syntax. I don't like to do this because it's like kind of confusing. I don't have to do it unless if I have to. But this is just like a show and example how you want to print like specific data frame, specific columns, right? Um, so so now think about your data. The newest house in your data isn't that new. It's about 9 years old. A few potential explanation for this. They haven't built new houses where this data was collected. The data was collected a long time ago. Houses built after the data publication wouldn't show up. Um, if the reason is explanation number one, does that affect your trust in the model you built with this data? What if the reason is number two? How could you dig into the data to see which explanation is more plausible? Check out the discussion thread. Okay, so it is for you for your homework. You can try to answer these first two questions, right? Um, um, I don't even know what is the what is the question I'm trying to answer here. Um, it's just suddenly it's like it feels like jump into asking questions that I don't really. There's a disconnect here. Yeah, okay. So it says that the newest house in your data isn't that new because it's like um 9 years old. This is like the newest, right? What was the question? Or why? Why is that so? Okay, so one of the explanation it says they haven't built new houses where this data. Okay, so yeah, that could be right. And then the other explanation could be the data was collected a long time ago. Okay, that's another reason. Yeah. So if this is the first explanation that that the houses they haven't built the houses since 2010, would you trust the model? Um, Probably I trust it with with that caveat in mind that the training data is not up to date because in probably in a real case the I know the data is not complete because I know probably there are some more houses that are being built after 2010, right? So ideally, I want to get all of those data until 2000, for example, now 2019. But for some reason, this is the only data that I can access from now. So if I were to use this training data until 2010, I'll be missing the 9 years of data, right? So when I use that model, I can use it as a point of reference, but I wouldn't really trust it with my heart. Probably I would trust it with only 70% of my heart, right? Whereas if I have all the data until 2019 on my computer and I can train that to build up a nice model, then probably my confidence level would be okay, 80% or 90%, right? So that's gonna be my answer, right? But if the explanation is number two, where the data is collected a long time ago, um, oh, okay. So that's my answer. My answer is for actually for number two. So the houses just keep on being built, but the data was not collected, right? So until 2010. For number one is they just stop building houses. Oh, so if really that's the case, then yeah, I would trust the data, kind of, because they literally stopped building houses for whatever reason on 2010. That's why the latest houses is on 2010, right? Um, yeah. So yeah, so I would trust if this were the reason more is if the first um, were the reason why the data was only at 2010 because it's just literally there's no more houses being built compared to if the reason for number two, if the data was just collected a long time ago and for some reason the houses keep on being built until now, until 2019, it's just never been collected, then I wouldn't trust the model so much because that means I haven't incorporated the last data into the training model, right? So that kind of makes sense. Okay, so hopefully this like help you guys. Sorry if you already learned this for the second time, but I mean, hey, come on, yeah, we can always like learn from second time, third time, fourth time, right? It's the more the better. It's kind of like we got kind of different things every time we learn, even hearing the same thing over and over again, right? So I'll see you on the next session. Hopefully, will be soon. Please leave a comments, questions, whatever. Thanks for listening.